Hey everyone, in this video I'm going to tell you about such a rare metal as rhodium, which we quite often don't notice, even when it's right before our eyes. In the periodic table, rhodium can be found in group 9, between cobalt and iridium. Moreover, this element is a member of the platinum group, because chemical properties of all the 6 elements belonging to it are very similar. That is why they are often found together in ores in Earth's crust. However, just like other platinoids, rhodium is very scarce, making up only 2 parts per trillion, which makes it the second rarest metal, being second only to osmium. Rhodium is most frequently found in copper-nickel ores, from which it is usually extracted, along with platinum as a byproduct. Because of its low concentration in ores, rhodium is quite expensive. 1 gram of pure rhodium metal costs more than $80, and this is just its market price. Rhodium is almost 2 times as expensive as gold. However, that high price won't stop me from running experiments with this rhodium droplet. Rhodium is almost 2 times lighter than iridium, yet it's more expensive. This metal's hardness is also quite high, being 1.5 times that of platinum. Now, let us consider this metal's chemical properties and see how similar they are to those of other platinoids. In a classic experiment, when I'm heating up a droplet of rhodium with a powerful gas burner, reveals how chemically stable this metal is. The heat twisted the tweezers, whereas the rhodium droplet only grew slightly darker. It's likely that it is simply covered in the oxide layer, which evaporated off the surface of the tweezers. Without wasting any time, I decided to test how malleable and plastic the metal is, and by the way, I also expanded the surface area of this metal for running further experiments. Forging metal, which is 2 times as expensive as gold, is not a big deal. However, in contrast to malleable palladium, rhodium turned out to be quite hard, and it wasn't easy to forge it with a hammer. As I continued to forge the rhodium drop, it broke into smaller pieces, which shows that rhodium is an extremely hard but poorly malleable metal. Thanks to its chemical stability and hardness, rhodium is used for coating silver jewelry. And yes, usually when we wear silver rings, we don't even know that we look at the surface of the metallic rhodium rather than on the surface of silver. Silver is coated with rhodium because this metal has a similar color, reflects light well, and protects silver from oxidation. In spite of being chemically stable, silver forms black sulfide film on its surface. Because of that, it can quickly lose its shine. A thin rhodium layer prevents silver from fading, because rhodium almost doesn't oxidize in normal conditions in air, and it is also highly resistant to scratches and rubbing. So, next time you look at your silver jewels, try to see if they have the rhodium shine, which many mistakenly consider to be silver shine. However, let us not dwell on the shiny properties alone and learn more about other properties of rhodium. If a piece of this metal is soaked in concentrated nitric acid, the metal remains unaffected by such an acidic environment, which is yet another confirmation of this metal's remarkable chemical stability. However, when hydrochloric acid is added and aqua regia is formed, the metal slowly starts losing its electrons, forming hydrogen hexachlororodinate of such a red color. It is because of this color that this metal received its name rhodium, which when translated from Greek, rhodon, means pink. Palladium and platinum form solution of similar color in aqua regia, which is why these 3 elements are within close proximity to each other in the periodic table. If alkali or sodium hydroxide is added to a rhodium solution, the pH level will raise and the solution will become colorless. However, in spite of rhodium's fitness for ornamental uses, more than 80% of produced rhodium is not used for making jewelry. Rather, it finds more practical and efficient applications, such as in the production of automobile and motorcycle catalytic converters, which turn harmful exhaust gases into less harmful. Such converters use thin ceramic plates coated with precious metals powder, mainly made from palladium, platinum and rhodium. Each metal is usually responsible for a particular reaction. Rhodium very well catalyzes a reduction of nitrogen oxides to gaseous nitrogen, which in turn significantly improves quality of air in cities. In contrast to my previous Chinese catalyst, this one shows catalytic oxidation of propane very well, which confirms that it contains precious metals, including rhodium. Besides turning nitrogen oxide into gaseous nitrogen, the surface of the catalyst also turns carbon monoxide into carbon dioxide and burns up the leftover fuel. Usually such reactions run at 415 Celsius degrees. By the way, along with exhaust gas, such catalysts also release particles of precious metals. That is why it's possible to sift platinum and rhodium from raw dust. In some densely populated countries, this doing so might even be more effective than just collecting and dumping such dust into a landfill. Rhodium powder is used not only to make car catalysts, but also to make smaller devices, for instance such as this catalytic hand warmer. This technology was originally developed by Zippa. This device operates on a quite simple principle. First, it needs to be filled with 40 ml of a lighter fuel, which is a mixture of hydrocarbons. Then you need to pouch such a cap with a special glass fiber, coated with a precious metal powder. If to look at it under a microscope, it's very hard to see any precious metals on this catalyst. However, when the catalyst is heated up with a lighter, we can immediately notice a catalytic oxidation of the fuel on the surface of the plate. In the dark this reaction is even more obvious, and when I blow air at it, the additional oxygen makes it glow even more intensely. I suppose that is happening here is flameless combustion of hydrocarbons powered by the rare metals, including rhodium. Usually our different ketones are the product of such a reaction, which is why the hand warmer is designed not to exceed 60 degrees Celsius. When inside a special bag, it will only reach the human body temperature. Besides being used for catalytic reactions, rhodium is also used for making highly durable thermocouples and for coating electrical contacts. This metal is also used in nuclear power generation. It is used in detectors measuring neutron flows. However, not all the reactors have such detectors. Basically, there are all the applications and properties of rhodium. To sum up, we can say that today, when lots of people wear silver jewels or eat food using silver cutlery, in most cases, they don't even know that they contact with such an extraordinary and almost invisible metal as rhodium. For the provided rhodium pellet for the experiments, I'll thank the company novaelements.com.